Okay, we're ready for our second presentation. So we've been doing a bunch of work with NIST and the NCCOE on SSO for first responders. It's not just about first responders, the best practices around AppAuth and the BCP that William Dennis and I have been working on apply to everyone, but we have funding to sort it out for first responders, so what the heck. So we have Adam Lewis from the Motorola CTO office and Mike from the same place, who are going to give us a presentation on what we've been doing for SSO for public safety and first responders.
Good morning, and welcome to the last day of the conference. So we are from Motorola, and we are security researchers in the Chief Technology Office, but I always have to begin every presentation with a disclaimer. We do not make cell phones. We did once upon a time. We divested from that a long while ago, but what we do is make solutions for first responders, so think fire, police, medics, as well as some federal governments and militaries. And while we don't make cell phones, we do make mobile native applications, and lots of them. Each one of these are purposely built for first responders to enable mission-critical workgroup communications and mission-critical real-time situation intelligence. And it's not just native mobile apps. A lot of these apps are also going to be web apps and JavaScript apps running inside the browser or on back-end servers exposed through web pages. And these applications, like a lot of enterprises, are going to be accessed through a variety of places. A lot of these back-end applications are going to be running inside the home agency, but a lot of them, like everyone else, are going to be running inside the cloud. And nations around the world, so including the United States and the United Kingdom, are building out nationwide first responder networks, such as FirstNet or the UK Home Office system. And then agencies are also looking to share information, open up their doors to each other. So you have native apps, web apps, user agent-based apps, accessing services in their home, in the cloud, in FirstNet, and between agencies. And what we cannot have is the first responder spending the first 20 minutes of every shift trying to log on to all their applications. So it becomes evident that we need an ecosystem to solve this. And an ecosystem properly is going to have three things. It's going to have to be secure, because this is public safety, and you're not mission critical anything if we're not secure. And it has to be usable, and if you could tell by number of security domains, it's going to have to be interoperable. And the best way to build these ecosystem that's both secure, usable, and interoperable is going to be on top of open standards and leveraging open source. And it's the last day of the conference, so you should know by now that we have a plethora to build on. So the IETF has given us OAuth, which is becoming a universal solvent for bootstrapping, all kinds of applications with tokens that can be used to access RESTful APIs. The OpenID Foundation gave us OpenID Connect, which adds an identity layer on top of this, allowing us to access web pages. And the W3C and the Fido Alliance has now given us, for the first time, a real standards-based viable path to finally eradicate the password once and for all. And the open source community has given us AppAuth. Now, AppAuth does two things in particular. The first thing it does is it gives us a very simple way on mobile platforms such as iOS and Android to implement the OAuth and OpenID Connect flows. Now, I have been a very long fan of OAuth, and it is very, very cool. But the flip side is it's actually been proven to be very, very hard to implement on your own. There's a talk at Black Hat last year that got a lot of press, 600 Ways to Die with OAuth. It's really important to understand that the OAuth standard is sound. Standards don't break, implementations do. So what AppAuth does is give you a very simple, easy way to implement OAuth and OpenID Connect and to do it right and to not risk any of the 600 different ways of death that Black Hat advertised. It gives you very simple ways to request an access token and swap that access token for refreshed access tokens. The second thing that AppAuth gives you are something called custom tabs. Now, I'm talking about AppAuth. It does go across Android and iOS. I'm going to demonstrate it on both. There's been some news with iOS lately. I'm not going to get into it here. It may break some of this, but there's also a lot of work going on to work with Apple to make sure this stays the same. So the second thing AppAuth gives us is allows us to open up a browser directly inside the application. So well so and so customizable that you can barely tell the difference between what's the browser and what's the application. And what it gives you is a shared cookie jar, which is incredibly important because this is what's going to enable the SSO magic across web apps, native apps, and user agent-based apps. In fact, it's so good that if you consider these 3 screenshots of one of our mobile applications, which one is the native code and which one is running inside of AppAuth? If you stare at it long enough, you can figure it out. It's the middle one, and really the only way you can possibly know that is because you see a small link up there. But to an average user, who can tell? It literally looks exactly the same, and it's very, very fast. Okay, so that's what it does, but what I want to do is really quickly show you exactly how it works, and then show you a demo of it working. So what we have on the screen on the left-hand side is an Android device with 2 native applications running on it and the AppAuth library. And what we're going to show in the first use case is a first native application that's attempting to access a resource server, so a native API, in its home agency. So using the API, the first application will basically request an authorization code from the AppAuth library. The AppAuth library will invoke the custom tab and basically perform an OAuth authorization request that hits the home identity server. Now, what happens next is extremely important, and I hit on this every time I talk about this. And you don't have to say this out loud, but everyone needs to repeat in their mind that this part here is very, very, very super important. And the reason is if you look at the picture up there, this user authentication is being driven between a server and a web browser. And this is important because you'll notice that neither the resource server nor the application are seeing any of this. And this is what's going to enable us to move from a password in my demonstration to plugging in a strong authentication like Fido in the second demo that we're going to show with 0 code changes, no development changes. And this is absolutely huge. This is one of the most important things about OAuth. The second thing that's important is that when it comes back, the authorization response that gives the code back to the library is going to install a cookie inside the custom tab. And if you remember, because that custom tab is the actual system browser, that cookie is going to be shared across a number of different flows that we're going to show in the next steps. The rest of it is pretty straight vanilla OAuth. The AppAuth library will return the code to the native application. The native app will then present the code back to the AppAuth library, which will swap it for the access token. And the application will present the token to the resource server and access this API. The user is effectively logged on at this point. Now, in the next use case, we're going to have a second native application. But this application is going to access a resource server in a foreign agency. It could be a foreign agency, it could be in the cloud, it could be in FirstNet. The point is, it's not in the first responder's home domain. The flow starts out the same. The app simply asks for an authorization code from the AppAuth library. And the AppAuth library, just like last time, will turn around and spit out an authorization request back to the foreign AS. But it doesn't have any authentication at the foreign AS yet. But the great thing about these technologies, OAuth and OpenID Connect, is that they layer beautifully together, so we can actually run OpenID Connect inside of OAuth. So this foreign AS now suddenly puts on the hat of an OAuth client and does its own authorization request, this time to the home domain, picking up the cookie context this time. So the authorization code is returned to the foreign AS without ever prompting the user for any form of primary credentials. The foreign AS swaps the code for the access token, or the ID token, excuse me, and the user is now authenticated, and the authorization code is returned back to the application, which will then present it back to the foreign domain, swap it, get the access token, refresh token, and we'll access the backend resource server. All right, so we have now done a native app in the home agency, a native app that's accessing a resource server in a foreign domain, and finally, the first responder launches the Chrome browser because they now want to access a web page, let's say hosted, let's say, for example, in FirstNet, which is now a third security domain. So they open the web page, and the web page is a protected resource and requires user authentication. So this web page at this point will perform an authorization request, or more appropriately, an OpenID authentication request at this point back to the home agency, once again picking up the cookie. The cookie authenticates the user to the home agency. The authorization code is returned to the FirstNet web service at this point, which swaps it for the ID token. The responder is authenticated, and the protected resource is returned. Okay, so we're going to now ask the demo gods for a blessing. We did our sacrifices before the meeting. So this should go off without a hook. All right, so what I have here are basically 3 native mobile applications, and okay, I guess you're all going to see my, good security in practice. So what you can basically see is I have, 3 applications. I have a main application, I have a mapping application, and I have a messaging application, each one expecting a sign-in. So I will do this in the first one. What you're actually going to see is, we're going to, at this point, this whole thing is being driven through this custom tab that I talked about. So I will go ahead and authenticate. And I will use my, I did plan for this one. I have a really strong password, CIS demo. Okay, and I am logged on. And at this point, I can go ahead and launch any of the other applications and sign on, and we're basically in. And these are our applications, but following this pattern, this would work with any third-party native applications. It would work with any website or any thing running inside of custom JavaScript. And what this does now is allow us to, as I said, bridge from passwords to something much better. So we want to talk about how we've implemented Fido in this. And so Mike is going to get up and talk to you a little bit about Fido and how it's a very mobile-friendly solution and very strong authentication. And it's really important to understand that once you implement this pattern, there is going to be no code development, not on the back end, not on the front end. Once it's AppAuth-enabled, you can seamlessly swap out different authentication methods and plug and play them. Okay, so Mike.
Thanks, Adam. So my research into multi-factor authentication was bounded by 2 clear requirements. One, the solution, by the way, you can't see the TV when it's hidden behind the podium. One is a great user experience, and the other was the solution had to have strong security. And through that, I was led to the Fido Alliance. And then specifically for me, there's one of the modes is called UAF, Universal Authentication Framework. And I had looked at that specifically because I like the idea of the phone as your authenticator. So what are the benefits of Fido to the public safety market? And quite frankly, it's the same as any market, any other vertical. Public safety is very keen on standards-based solutions that allows interoperability and sourcing from multiple vendors, right? This is really important. These other topics have been hit on quite a bit this week. No secrets on the server side, right? It's just a public key that is stored on the server side. Also, the biometric with UAF never leaves the device. And then finally, there's no password to phish, there's no phishing, and this is a great benefit of Fido solutions. So, my phone as the authenticator. The one thing, I learned this at college with my kids, is they never forget their phone, and quite frankly, neither do I. You can forget your keys, you can forget your wallet, and maybe you can forget a child once in a while, but you don't forget your phone. The other thing is the authenticator, or these devices, these phones, are becoming very powerful. The number of sensors on these devices is just amazing. And all the newer devices come with secure parts, right? So the trusted execution environment on Android, secure enclave on iOS. Commoditization, isn't it wonderful? I mean, we all get to take advantage of it for relatively cheap price. So what do we do with this? Innovation on the edge. So on the one hand, you have a lot of sensors that you can use directly for biometric authentication. I'm a big advocate of having more than one biometric enrolled on your device. Adam likes to tease me about a presentation I gave on voice biometrics, which I'm actually going to give today, in which I became quite ill. I lost my voice, and I sure wish I had facial biometrics at that time. So anyway, so you get a lot of sensors. I'm an advocate of enrolling a couple biometrics. But the other thing I wanted to talk about is all of the sensors on the device and what else you can do with them. We talked in the past few days about risk-based analysis, behavioral analysis that you can do to identify whether you think this user is exhibiting certain things that maybe it's time to re-authenticate them. So that's one area you can do some intelligence on the edge. The other I'd like to bring up is context. And this is particularly important in public safety. Given the user's context, what is the best way to authenticate them? If they're in a very noisy environment, it's probably not the best opportunity to do a voice biometric. If it's very dark, don't use a facial. If it's 20 below northern Minnesota in the middle of the winter, it's probably not the best time to ask for fingerprint. So context is very important, and I think we can do a lot of things on the device to determine the optimal way of authenticating an individual. After yesterday's keynote, I was thinking about removing this slide, and I wanted to keep it because there was a keynote on biometrics that was just excellent. So on the device, all of this is occurring. By the way, what happened to my template? It got mixed up on your Apple. Should have used a PC. So on the device, you have your sensor. The sensor grabs a lot of the, can extract features from your biometric that you're enrolling, and from that, it creates a biometric template, which is nothing more than a series of ones and zeros. And this is what is stored on your device. And it doesn't matter what kind of biometric it is. They all generally follow the same pattern of extract unique features and then run it through an algorithm to generate a template, store the template, whether it's a behavioral biometric, something you learn, or whether it's physiological. I mean, it's just part of your DNA, such as a fingerprint. That biometric is enrolled. During authentication, then what happens is you provide another sample, and essentially the two templates are compared, and it's called a matching function that runs this comparison, and the output is a score, and that score is compared against a biometric threshold, a match threshold. Now, you can tune biometrics. This is not, I guess, real commonly known, but dependent upon where you are in implementing, or if you're the vendor, or if you're doing an aftermarket biometric that you're installing on the device, some vendors give you some parameters that allow you to adjust the security of the biometric based on your use cases, your scenarios, the customers you're providing these services to. Generally speaking, you want a false acceptance rates of around 1 in 100,000, so 0.001% or better. And user experience seems to be considered good if you only have a false rejection. You supply a sample, it still rejects you, of about 3 or 4 in 100. And biometrics today easily meet this. Many of them do. The other thing you can, another parameter you can turn on or off or tune is liveness detection. And so I just wanted to mention that these are parameters that some biometrics allow you to tweak. So now let's apply this to Fido UAF. So factor 1 is something I am. It's my biometric. I supply that. It does the comparison. If the user verification passes, it unlocks factor 2, something I have. What do I have? A private key that I registered when I registered my Fido authenticator initially. So that private key is then used in a public crypto challenge response with a back-end server. In the demo we show, we have this integrated with our single sign-on ecosystem that Adam was showing you, those flows. Upon successful completion of factor 1 and factor 2, you're logged in. And without further ado, I guess I will run a demo using voice biometrics integrated into our cockpit app that will then launch a Fido authentication, a Fido UAF. So, Adam, how do you run your Mac?
Sorry, it's a PC user.
Thank you.
Sure.
Now the Wi-Fi hasn't been all that great today, but we'll give it a whirl. So, launch cockpit. Sign in. We can talk about this okay in the Q&A. Log me in. And I'm in. That's multi-factor authentication using UAF. That is the end.
And just one thing to add to that, in the NIST demo, we didn't have a phone here to do it today. We have a number of different setups, but we did this exact same demo for those of you who are security key guys. You can do the same thing using U2F and a YubiKey. This is the power of the AppAuth pattern. You can literally, plug and play. And as you heard Alex say yesterday, this web authentication, which is going to embed Fido, is going to be native in most of these browsers pretty soon now. So it's going to be a really wonderful time for all of us in this space. Yeah.
We have our implementer here, Dan, so if there's really technical questions, we architects are really good at slides.
Okay, so we have a few minutes for questions. George, do you want to start swapping the laptop, or you can do that while we do questions? Try and make it efficient. Anyone with questions? Yes, be in the back.
So in your previous model about all the tokens being sent to the browser first, are there any downsides with all the tokens stored in the browser for any long-lived sessions?
You're talking about token storage in the browser?
Yeah.
The man who handed you the microphone is the best person in the world to answer that question. So I'm punting.
Since you asked, the tokens that are generated aren't actually stored in the browser. They're stored either in an application or a secure element like a U2F key. There are cookies that wind up being able to map the sessions that are stored in the browser, and we're recommending using token binding once that standard is available so that they can't be exfiltrated. But it's, at the moment, with bearer cookies, it's as good as security as people use, so it's not any worse. We expect to make it better with token-bound cookies.
And John, I wasn't sure if Chaco was asking about the cookies or if he was asking about the implicit flow. Were you asking about the implicit flow or about the cookies? Yeah, so the more interesting one is where the tokens are stored in the implicit flow.
Well, you can't and shouldn't do that with an implicit flow. Would be my answer, yes. On my to-do list is best practices for the implicit flow. There are the security of a public client using the implicit flow without eventual token binding, or service workers, etc. There are things that will work on some browsers which let you do things better. There isn't a generic solution that actually lifts the level of implicit apps to the level of a confidential client. There's still ways of exfiltrating things that are stored in JavaScript from a particular app. So most of what we've done on the mobile devices with native apps using Pixie, etc., to make it secure. There's still work that needs to be done to make applets in JavaScript be as secure as that. At the moment, I'd like to have a better answer, but there really isn't one.
So you kind of hinted with the answer to my question. So basically, all the apps you are actually using is using implicit flow.
No. All the apps we were using the code.
They're using the code flow.
Okay.
Yeah.
Then my question is, how does each responder register their the app, the instance of running on their device?
How do they register the app? They don't need to. The developer registers the app.
So the apps, all the apps running on each individual responders all have the same secret?
No, so there are no there are different OAuth flows, right? So there's the implicit one that's used for browsers. There is a secret that's used for backend web servers, for confidential servers. But for native apps, they're considered public clients. So they don't register, but I kind of glossed over it just in interest in time. But there's something called PXE, which basically allows a native app to dynamically on the fly come up with the secret so that the code cannot be intercepted when it's flowing in and out of the browser.
Okay, we have Justin itching to answer.
Hi. If I can jump in, because I literally just answered this for a bunch of people like last week. There's a lot of confusion between OAuth public clients and the OAuth implicit flow, which effectively requires you to have a public client. You can have public clients, which is clients that don't have individual per instance secrets, and still use different flows. It makes sense in the code flow in certain circumstances, especially if you're using PXE, because then you get a per transaction secret that's only known to that instance. And that does a lot to protect it in the same way that a client secret would if you had a per instance client secret.
Right. So what we're doing at the moment is public clients using PXE. Nothing stops an individual SaaS provider from also doing dynamic client registration and also bumping up the security that way.
Assuming that you're using the Knock Lab as your biometric authentication provider here.
I'm sorry, can you repeat the question?
So the question was, for the UAF biometric authentication, whose SDK are you using?
Okay, so yeah, currently we're working with Knock Labs for both the...
The biometric was from Sensory. That was the biometric that we were running.
So this is the beauty of interoperability standards again. So we're using a Knock server, currently with the Knock Fido client, but that client will eventually be absorbed into either the browser or the operating system stack, and then using a third-party Sensory authenticator that all work together.
So I'm going to ask a question. UAF is normally integrated by individual applications integrating an SDK from Knock or somebody else into each app. That obviously is not the pattern with AppAuth, where apps are isolated from the authenticator. What magic is Motorola and the NCCOE pilot doing to allow a single authenticator on the device from someone like Knock to work across multiple apps and have a single identity?
App links.
There is an Knock provided external authenticator, which...
So the Fido UFA client becomes an application that is registered to react to an AppLink request. So it's registered as a handler of an AppLink, and that's what launches our Fido UAF client, which then starts the Fido authentication.
So a bit like the way that U2F is invoked on Android.
Yeah, and so in fact, when you saw that OK, I had to touch the screen twice. That OK was AppLink. Currently today, Android requires user permission to launch a native app, and so that's why that OK was there.
I should just mention briefly, since I'm on the Android team, that was a specific security requirement for AppLinks so that they could not be, well, I just want people to understand the context there. Obviously, from a user experience perspective, for that particular use of AppLinks, you wouldn't want to involve the user, but because there are a whole bunch of things we want to prevent that are bad security usage that could happen behind the scenes without the user knowing, there has to be some user interaction.
And Andy, how are we going to get rid of that?
This is an interesting topic of discussion that I don't think the creators of AppLinks and Android fully envision these kinds of use cases, and it's a great opportunity to do so.
The correct answer would be, we're going to get rid of AppLinks because we're all going to move to web authentication, which is going to be built in natively into Chrome, which the Chrome team assures me they are madly working away on, so that the web authentication APIs will be exposed in the Chrome browser. Ian is avoiding nodding his head. so that both on the desktop and on Android, you will use standard W3C approved web authentication standard to interact with the various authenticators on the device, and we won't need to go through the sort of hacky app links workaround that in order to deploy U2F and UAF that have been initially deployed. So it's all going to get better and more seamless in the future.
And that's a good point. If
The
we could-
Chrome team and Ian doing AppAuth and OpenYOLO gets things integrated.
Yeah, for anybody who wants to see a U2F security key demo, William, do you have it up with you right now? Yeah, can you show it to anyone after if they're interested? So you can see a YubiKey touch, and because in this case U2F is in the browser, you don't see that. And that's what we'll eventually have with UAF once web authentication is complete. So anybody who wants to see a U2F demo with the YubiKey, William has that running on his phone from the NCCOA.
Okay, thank you. We should move on to George.